Okay, so we're going to speak about the VC dimension. I said it. Let's start with a very simple example. So assume our hypothesis set is just a set of thresholds on R. Okay, so this is the hypothesis set. The hypothesis set is a set of thresholds on R. Basically, these are the thresholds, they are in R. Okay. So we think so that's we may learn by learning we mean choosing a threshold, and essentially we will label any points that is below the threshold as a minus, say, and any points that is above the threshold as plus. Okay. That's my hypothesis set. So I can learn, basically I get samples of points that are labeled by minus and plus from any distributions, and I need to pick up a threshold. So my learning algorithm is required to pick up a threshold that best generalize the points that I got. That's the learning task, and that's the hypothesis set. And so the question that we want to ask is, what is the VC dimension of H? Now, if the VC dimension is finite, then we know by the fundamental theorem that we can learn using in this setting. Okay, but the question is, what is the VC dimension? So I need to define what a VC dimension is, and I'll do it in stages. So first I'll explain a term that is called shattering set. Okay. So what is a shattering set? A shattering set is a set of points, in this case in R. Okay. So in our case, in our setting here, R is the set of points from which we get the data samples. Okay. So it's going to be a set of points in which any labeling that I give on that set of points, I have a hypothesis from my H, my hypothesis set, that will learn it. Okay. So let me give you an example. So for example, here I choose these 3 points, any 3 points, and I decide that the label here is a plus, the label here is a minus, and the label here is a minus. Okay. Now, is there a hypothesis in H that will exactly answer these answer plus on this point, minus on this point, and minus on this point?
Yes, infinitely many such hypotheses.
Give me an example of one.
Between the plus and the minus.
Between the plus and the minus. So you're interpreting the hypothesis set to include both the case of minus, 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 and then plus, and the case of plus, 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 and then minus. Let's go with the flow. Let's go with your interpretation. So I can also define the threshold to be plus, 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 plus when it's less than b, and then minus, 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 minus when it's bigger than b. Then this point here, okay, will explain these 3 points perfectly, right? Because it will give a plus here and a minus here and a here. Okay? So as Balal said, this threshold here perfectly explain the labeling here. Okay? Now, let's try another one. Let me do this. Okay, here we have another, again, 3 points. And now the labeling is like this, minus, plus, and minus. Okay? Now, can we choose a threshold that will explain this exactly?
No.
No, why?
It's like the XOR problem, non-linearly separable data sample.
So can you explain?
I mean,
can you explain in a concrete manner why it's true? It's impossible to do it, but can you explain in a more concrete manner why we can't define a threshold here that will explain the labeling perfectly?
yeah, because whatever threshold you choose, two of these signs, I mean, two opposite signs will be on the same side.
So you can't choose a sign for it, right?
Yeah.
Excellent. Okay, so like if I choose the threshold to be here, then here on this side there's going to be the same sign. Regardless if I choose minus or plus, it's not going to be correct always because this is minus and this is a plus. Okay, so it's impossible to do it. So what we say is we can't shatter 3 points. Okay, with the thresholds.
But if we take it to or I mean embedding it into 2 dimension, then it will be.
We are in 1 dimension. Don't change the game.
Yeah. Okay.
We'll get there. We'll get to even we quickly will get to basically n dimensions, but slowly. Okay, here's another example, another question. What about two points? I label them in any way I want. Can I shatter them? What about this? Can I shatter this one?
Yes.
Yes. I just put a threshold in the middle and say that it's minus here and plus here, and I'm good. What about this one? Can I shatter this one if I label it like this? Can I shatter this one? The 2 points here, both of them are a plus. Can I shatter them?
Yeah, take one to the right or to the left.
Yes. So I'll put a threshold here and say everything here is a plus, everything here is a minus. If I have both of them, you see where I'm going. If I have both of them minus, okay, again, I'll be able to do this, right? Because I'll put a threshold here and say everything here is a minus, everything here is a plus.
Right.
Okay. Now, if I change the plus and the minuses here, I just keep the threshold and change the definition, and I can do it. So here I have a set of 2 points that I can shatter for any possible label. So any possible labeling that I give these 2 points, I'm good. I'm going to be able to describe it using the thresholds, right?
Mm-hmm.
So we say that the set, we say that H can shatter 2 points, but H cannot shatter 3 points. This is what we found out up to now. So H, what can H do? It can shatter 2 points. It can shatter 2 and cannot shatter 3. Okay? So we say that so there exists a set of points of size 2 where we can shatter, and no set of 3 points can shatter it. So we say that the VC dimension of H is what?
2.
2. So we learned 2 things here. One is that according to the fundamental theorem, we can learn using H. And then we learn another one, which is interesting, that you can learn over sets of hypotheses that are infinite. Because if you think about the basic proof of back learning, you may think that you can only handle finite set of hypotheses. So the answer is no. You can handle also infinite sets of hypotheses. So if you like to play around with this, try to think about the following problem. Think about, R2, and our hypothesis set is any hyperplane. So any line that makes everything here plus and everything here minus, or vice versa. Okay? Any line. This is your hypothesis set. So your hypothesis set is any line that makes one side of R2 be labeled as a plus and the other side is a minus, or vice versa. And try to think offline, what is the VC dimension of this hypothesis set? Okay? So that's anyone who wants to play around with it, it's a nice exercise now. And if you know the answer, then try to do it for RD as well. Once you know the answer for R2, the answer for RD will be easy to come up with. Any questions or comments up to now? Okay, so thank you very much for joining, and we'll continue next week.
Thanks, Eitan.
Thank you. Bye-bye.
Bye.